Hello guys, welcome to another FX series video. In this session we're gonna cover how to create a realistic candle flame in Maya using 3D containers. So as you can see, that's the final result that I've put together, and we are going to achieve that in the quickest way possible. So without any further ado, let's dive right in. Alright, here's the scene in Maya. Very simple scene that I've put together. There's not much to it really if I show you it from perspective. It's pretty much just a disk with few simple objects. I have two parts to this wig. The first part is the base, which I'm not going to add fluid to, and the second part is the mane. The overall measurement for this is around 10 cm. So you can see the grid. I try to stay in the ballpark of realistic measurements. And it's a simple candle. It's not something too big, but just keep that in mind that everything in fluid simulation can change. The behavior of the fluid can change based on the scale of your scene. So if I triple the size of this scene, I may change a few things along the way. All right, so let's get to it really quick. First things first is to make sure that I am in the FX menu set. Then I'm going to go to Fluid 3D Container. I'm going to reset the settings. I'm going to keep everything same. I don't need any emitter because I want fluid to get emitted from the wig, the model. So I'm just going to say close and apply. This is too big. I need to bring it to the position. So I'm just going to do that. Also, the size of it is too big. So let's change the size to begin with. 10 by 10 by 10, definitely it's way too big. I'm going to reduce this to maybe 2, 3, and 2. And if I need to change that before I make my connections, I can definitely do that. I need to bring it up, translate Y, set it to something like 8 units in positive Y, and that should do it. I'm going to switch back to fluid shape container, and this is something that we discussed in torch flame video. If you haven't checked that out, I go through more details, and I assume you already know a little bit of basics about contents details, but if you don't, make sure to check that video out. I put the link up on the screen. Now, we're going to increase the base resolution to something like 60 because we would like to get something to begin with. Otherwise, we won't be able to see anything. And now let's make the connection because if I press play, I'm not going to see anything. There is no fluid in here. There is no emitter in here. So selecting from the outliner, I'm going to select the wig main, shift select the container. I'm going to go to fluid and add from object, or rather emit from object. I'm going to call it source, as I usually do. Apply and close. Now if I go and check, I do see a small touch of fluid. Might change the background so it's visible. Yep, with that. I do need to simplify the look of this container. So I don't want to see the resolution here. So I'm going to go and select the fluid and go to its display and send the bounding draw to bounding box. Later on, I'm going to probably set it to none at all. I can do it right now even and basically get this over with. Slice per voxel. Higher values in this produce more detail, but reduce the speed, and you won't get that in the render. So I usually lower it down. So let's see what we're getting. Yeah, it's definitely much easier to see now. Now I'm going to go to emitter, which is now under the geometry that I have from the outliner. What I don't have is enough rate, enough density, and usually I tweak that via basic emitter attribute on the emitter node via rate percentage, and 100 is usually very, very low. I'm going to start with 600. I might bump it up even to 1000 based on the number of fluid or the amount of fluid that I would like to see. That's much better now. You can see it's bouncing, and then because I set boundaries to both sides, it basically bounces on the sides and of the top of the fluid. Now, while I have this menu here, you know that I do drop down the fluid drop off to 0. Basically, you're setting drop off value for fluid emission, and I do not wish to have any drop off value in here. Also, while I'm in this window, let's set the fuel method to no emission because we're not using any fuel. Now, I'm not going to tweak fluid emission turbulence and emission speed attributes, since I do not want to have initial velocity or inherent velocity for that matter. This has to be a very tamed, especially formed type of fluid. And as soon as you enable those, then you're dealing with more of a steam or smoke looking fluid rather than a flame fluid. So I try to stay away from those for the effect that I'm going with for this tutorial. Now, with that done, I'm going to go back to fluid and collapse display and go to my contents detail density. As you know, this is a very important submenu, and as I said many times, you need to master these attributes over time. There are few very important attributes that you almost always need to tweak, and we are going to go through some of them for this tutorial. Now, for buoyancy, I need more buoyancy. I'm going to set it to 5. For dissipation, I want my fluid to dissipate, not to go to infinity, obviously. So I'm going to set dissipation to 1. I need a tad of diffusion, and we do need diffusion usually for candle flames effect. Usually I advise against it for other types of fires, but for candle, definitely diffusion can help. Maybe 0.1 would be a good starting point. And for the first time, I'm going to use this attribute tension, which I really like. Tension pushes density into rounder shapes and make the density boundary more defined in the fluid. And as a result of that, makes the fluid look taller. Now, one thing you need to be mindful of is we are going to use turbulence for the majority of this tutorial, and you can set these attributes to whatever you want, and you may not even see it in the render because you do see temperature, but I still need to tweak that for my opacity column in the shading submenu. Now, if I go, and for now, I'm seeing density anyways. Look at that. With small detail and with small adjustment, we do see the shape of the fluid. I quite like that actually. The reason that we're getting such soft and tamed flame is because of the diffusion, surprisingly. If I turn off diffusion, you can see we're still going back to the flame that we have, and you can see how powerful this blurring effect is, and we do need that for our candle flame effect. Now, before I go to temperature and make some adjustment there, I think I need to pay a visit to dynamic simulation. And dynamic simulation and attributes in here help me to get a much better result and form the fluid much better. And it has an effect, an impact on both density and temperature. So let's set the damp to very low value, 0.075, which is considered an okay value, almost a medium close to high value for damp, because it suppresses the flow in the container, and very small value can make a huge difference. I increase substep to 3. This increases the number of calculation per frame, obviously, and solver quality to something like 35, and that increases the number of steps. Also, while I have this window open here, I may want to increase simulation rate scale. It does scale the time step using in emission and solving. So you increase this, your simulation occurs faster. I'm going to go with, I don't know, maybe 2.75. I can even use 3. Yeah, that's much better now. I think it's time for me to pay a visit to temperature attributes and tweak some of the attributes there. So let's go to content details and temperature. Now you can see that this is not on. Now the reason that it's not on, because if I go to contents method, you can see temperature is set to 0. So we have to make sure that we have dynamic grid on, so temperature gets calculated, and based on that, if I go back, you can see the attributes are no longer grayed out, which is great. Now, before I actually tweak that, I think I need to make a small change to my emitter fluid attribute. So if I go and select the source, which is my emitter, and fluid, a fuel method. Now in here, heat method set to add, which is correct. I am going to increase this more. We don't need to worry about density, so I'm not gonna even do that. So usually for fire, I do polish this attribute. I may change it later, but let's start with a good starting point, which is 1.3 in this example. Now I'm going to go back to my fluid and let's make some changes in here. Now temperature scale of 1 sounds good. Let's go to buoyancy. I do need lots of buoyancy, so I'm going to start with something like 70 or 60. Dissipation, I want my temperature to dissipate, and diffusion of 1 is enough. I don't want to increase this value too much because simply it makes shading process more difficult. It makes the whole look of it too blurred. I do add a touch of turbulence in here. I will add a real turbulence via turbulence node, or in even an external force field turbulence, but for now just add just a little bit of that to get a little bit of movement, so it's not completely rigid, and tension of 0.25 will do just fine. So I'm just going to reply. We don't see much of a difference, obviously, because we're still mostly looking at the density. So let's go and have a look at our shading. A lot happens here every time you deal with fire. So I'm going to set transparency to maybe 0.15. Here's my reference, and you can see the flow, the coloration, the size of the flame, and it makes a huge difference. And that's the type of coloration that I'm going to apply using shading rollout. For transparency, and again, it's quite an opaque effect, so I may even reduce transparency more. We do need to have drop off for that. That is actually a very, very important attribute that I always change. I've seen artists use sphere and cube. I tend to use Y gradient, and Y gradient is going to look at the Y axis and it's going to start fading the base of my fire, which is usually the case. So when you change that, then you definitely need to change the edge drop off as well, because 0.50 is very, very, very low. So maybe 0.46, and that defines the fall off region, and fluid won't take place in those areas at all. So if I do that, you can see it kind of eats in the fluid from both ends, from the tip and from the very end of my fluid. And again, it would be we're going back to tension and we're going back to dissipation, and these are the attributes that you need to constantly change to get that sweet spot, the result that you want. And these are not all guesses, these are all figures that I've already played around with. You can rely on them if your scene scale matches mine, but obviously you kind of need to know what each attribute does before you change them. So let's see what we're getting. Not too bad. For color, I tend to zero that out, switch back to 0, because I really don't want to see density. I'm not interested in density. I'm more interested in incandescence. And soon enough, we need to bring up a render window to just see the feedback via our IPR. I never ever rely on what I see in the viewport. Now, before I go to incandescence, there is one more attribute I would like to change on my fluid, and that not the emitter, but the fluid container, and that is a little bit of velocity. So I'm just going to introduce just a tad of swirl. Now I'm going to bring my incandescence window, and I'm just going to increase the pace of the video and mute the microphone. You'll see the end result at the end. So that should do it. Now I'm going to set my input bias to something like 0.9. So you kind of see the flame now. Without content bias, you really don't see much. So that attribute does push the look of what you see, because pretty much this value is a sensitivity of the color input. So you need to make sure that that number is high enough. Just so you know, this incandescence won't be affected by any shadowing. So I may go in lighting and enable self shadow and set it to a very high value. I really don't see much of a change. Even I can make changes here, still may not be able to see things the way I want. Now if I go and play, I get my lovely shape back. But if I render, I may not be able to see the pattern that I want. So let's do a quick test render with Arnold. So I'm gonna go to Arnold, render. So as you can see, the look is almost there, but I do not have enough intensity. Now let's go to opacity and change a few things in opacity, and it makes a huge difference to what we do. So let's bring up this opacity, and I'm gonna set the bias input to something like 0.51. And you can see as soon as you do that, you will get some really nice result. Of course, the pattern is off, and that's what we're going to fix with this value here. So let's do that really quick. Now, as you can see, we are getting a much better result using the opacity, and that shows how important this value is, or this drop down is, to shape the flame that we have. Now, I think we're reaching the point where I'm getting all the coloration that I want. So for the most part, the look of my candle is done. What I need to do now is to give it a little bit of interaction and interactivity. To do that, I can easily use my fluid container and go into contents detail. There are two attributes that I can keyframe to get the desirable look. The first one is the buoyancy that I can keyframe over time and get the look that I want. And the other one is strength for turbulence that I can animate and get the result. So I've gone ahead and just applied random keyframe on those two attributes just to show you for the turbulence. I used really subtle values. So from frame 1 to 35, no turbulence. From 35 to 50, 0.3 turbulence strength. And from 50 to 65, down to 0, 65 to 80, no turbulence. 80 to 90, only 0.15 value for turbulence. And from 90 to 0, just 0.15. And you can just change them. You don't see much of a difference as long as your values are around the same ballpark. Don't use a very high value, otherwise you see some really unpredictable movements. Now that's for turbulence. For buoyancy, in my temperature, I used much higher values. So from 0 to 25, the initial value was 70 and I reduced it to 60. 25 to 50, I jumped it from 60, doubled the value to 120. From 50 to 60, decreased from 120 to 80. 60 to 90, again increased the number from 80 to 120. And from 90 to 100, I used 120 to 70. And then in Graph Editor, I cycled them so it's going to loop. You don't need to worry about the rest of it. You can set it to 300 and this value will loop. And there's not much repetitiveness that anyone can notice about them. So that's how I keyframe them. Now I've already gone ahead and cached them as well. So if you go to Effects and Cache, create new cache, Maya Fluid, I've cached this render already. I've rendered 150 frames of this JPEG, nothing special, no motion blur. And let's have a look at the post that I've done for this, and it's just a couple of nodes that I added in Nuke to add that glow to the end result. So let's have a look at that. Now here's a super simple node tree that I put together in Nuke. Yes, you can go ahead and use AOVs to have subsurface scattering on a pass, have the flame on another pass using render setup and render layers. But again, the idea for me just to show you attributes inside Maya using fluid container, so that part of it can be another tutorial. For one glow, if I disable the second glow, the first glow just looks at the overall look. So adds a little bit of more glow around the flame itself. And I did that using a tolerance, a little bit of brightness, and changing the size. For the second glow, which is going to add more ambient type of glow to it, again, I tweaked tint, tolerance, and brightness, full saturation, and that's the result I achieved. I wrote the whole thing as sequence back again, and that's what you are going to see as final result. And this is the final look. AA sample of 5, subsurface sample 3. I hope you enjoyed this tutorial. Subscribe if you would like to see more tutorials, and I would like to hear your feedback as well. Thank you very much, and see you in the next video.